All right, this talk is RESTful Web API Patterns and Practices. And this we'll be talking about this notion of creating patterns that we can use over and over again in RESTful situations. So this is me. This is how you can find me on LinkedIn, in GitHub, and Twitter, and Mastodon, and all the social medias. YouTube, I would love to hear from you and learn what you're working on and what's challenging to you. Most of the talks I give are really things that I've learned from other people, and I'd like to learn from you so I can share it as well. So please connect with me. The content of this talk is actually based on a book I wrote last year, RESTful Web API Patterns and Practices Cookbook. You can pick that up as well if you want to dig deeper. This is going to give us a chance to kind of look at the big picture, but you can dig deeper in this book as well. And so what I want to really talk about is this notion of what pattern thinking is first, and then we'll talk about design and clients and services and data and workflow, all these situations where patterns can be really powerful. And then we'll kind of summarize a few things here at the end. So pattern thinking. What is pattern thinking? Why are patterns important? Why are they so valuable? So first of all, thinking in patterns or seeing patterns in the things you do is a way of understanding systems that you work in, help you design them, helps you even construct them. So this notion of thinking in patterns is really, really important. Another key element in pattern thinking is it relies on this notion of inductive reasoning, of observing a lot of similar situations, creating generalizations or abstractions about them, and then coming up with a paradigm or a way to think about this interaction in a generalized way. Think of navigating a list in APIs. That's a pattern. It's done specifically differently in lots and lots of places, but there's a generalized pattern. That's different than the kind of deductive reasoning that most of us learn, where we create a theory, we make predictions about that theory, and then try to observe through experiments what happens in the world. We're going the opposite way. We're starting from the real world and going towards abstractions. This notion of pattern thinking was made popular by Christopher Alexander in the 70s, a physical architect who talked about how certain things kept coming up over and over again in the design of physical architecture, buildings and communities and cities. And he used this way of talking about patterns as a way of teaching his students and readers how to think in patterns. So let's talk about patterns. Let's start with this notion of design patterns in APIs, patterns that we can use to help us design good APIs. We can use design patterns to help machines that are built by different people work successfully or interact with each other, even when those people have never met each other in the first place, because they have a sort of shared design. And there are a handful of patterns. A lot of them have to do with this notion of ensuring interoperability and compatibility and explaining things in a consistent way, domain vocabularies and what I call problem spaces. We'll talk about that in a minute. There are also ways to express interactions between. How do I perform a task? How do I read, write, approve, share, and all those kinds of things. And then finally, patterns that help you with these really important elements of any long-lived systems: repeatability, reversibility, extensibility, and modifiability. These are all patterns that you can start with from the very beginning, before you even build something, to start thinking about how to make your system design better. And I really love this describing problem spaces pattern. Often we think we're describing solutions. A well-designed system, a system that lets other people interact, actually describes problem spaces. What are the problems we have when we're manufacturing a product, or managing users, or doing book account systems? So this idea of semantic profiles, where we describe the participants, we come up with a vocabulary, and eventually even a navigation diagram that shows how you can move between elements in the system, are all a way of describing problem spaces with semantic profiles. The key in all these design patterns is to make designs composable. I can take a little bit of your system, a little bit of my system, and create a solution to a problem that neither one of us had thought of. So once we've gotten past this notion of client of design patterns, we can start thinking about client patterns, clients that actually consume APIs. Great API consumer patterns really make very few assertions about how communication works. Maybe they'll say you've got to be using HTTP protocol, you've got to be using JSON messages, and you've got to be using the domain for two-sided accounting systems. That's all. The what, the actual things that are possible and how they're connected to each other, what arguments are passed and forth, are actually supplied by the server, and clients need to be able to pay attention to those things. So client patterns have a lot to do with being protocol aware, understanding message formats, understanding vocabularies and domains, and that sort of thing. They also have the ability to pay attention to what happens at runtime so they can learn more about which formats are available or which document or message metadata is available at a particular time, how to validate inputs and outputs, how to use schemas and queries, and so on and so forth. And eventually this notion of how I can find controls, is there a form, is there a link, is there an action somewhere for me to work with. I also love this idea of maintaining state on the client level and clients having a goal themselves, clients knowing when they've completed a task, not necessarily a server. And again, an example pattern in this client category is managing representation formats. If you design your applications, your client applications, so that they're format aware, you can create applications where they can say, look, if I get this collection JSON response, I'm going to parse that separately than if I get a siren response or if I get a HAL response. And the important thing here is if in some future time a server starts giving you new responses, you just need to implement an additional parser rather than rewrite the entire client application, which is a really, really important and valuable pattern, because we can use these patterns to make clients adaptable to new situations. Now, we've talked about clients before services. That may seem a little unusual, but it's the consumer that's more important than it is the provider. The consumer is much more consistent and persistent than systems and services. So service patterns are really based on this notion of the idea of the contract. The services make promises. They make promises at build time and at runtime, and it's up to them to keep those promises throughout the change of all sorts of situations. So a lot of service design patterns have to do with preventing leaks from the internal model, from the data model or the object model, so that you can make changes on the external side. The API is the interface. It's not the actual model itself. And of course, there are lots of really common patterns: client preferences, content negotiation, vocabularies, definition documents, metadata, service health reports, all these kinds of things. Services, for the most part, have a responsibility to send lots and lots of metadata upon request. And then, of course, there's this notion of optimizing, improving discoverability, client supplied identifier, reliability, fallbacks in case something is wrong. Services also have a responsibility to make sure that the system continues to run even if the service is having a hard time. And one of the patterns I really like in the service group is this idea of discoverability, of registering a service once it goes live. So as soon as the service is up and running, it should register with a service registry where it keeps track of its reliability and uptime and other details, and gives connection details to anybody who wants to use, say, this payment service or this product management service. And of course, when the service shuts down for any reason or goes down unexpectedly, it should deregister from this live service registry as well, to prevent others from continuing to use that service. So building this into the service behavior, the ability to register and announce itself as available and pull itself from that registry when it's unavailable, is a key service pattern, because that helps us make services modifiable. We can take a service down, make a change to it, and re-register it. So just as we make clients adaptable, we want to make services modifiable. Now, there are a whole bunch of data patterns that are important as well. And data patterns are independent from clients and services because data kind of has a life of its own. Now, it's really important to remember what's come to be called Amundsen's maxim, something that I said over 10 years ago. Your data model is not your object model, is not your resource model, is not your representation model. Each of these are independent elements. But we're going to talk about the data patterns because data patterns affect so many of us so often in our lives. So a lot of these have to do with the same as model leaks for services. You want to make sure that you hide your data storage internals. I shouldn't know whether or not you're using a JSON document database or a SQL server or a file database or anything like that. That's not important at the API level. We want to make changes idempotent so they could repeat them in case the network goes down. And we want to hide relationships with internal actions. In other words, I shouldn't know necessarily that the customer and the customer orders have any kind of special relationship that I, as a user, need to know. We also need to be aware of this notion of information retrieval queries versus data queries. So there are query languages that are very mathematical that let you update and delete. Information queries are much more non-deterministic. Give me all the documents that have something to do with Mike Amundsen's last book. That could be lots and lots of information and lots of responses that may or may not have a high quality. That's a very different kind of model. Of course, there are lots of things about caching and modifying models in production and limiting large-scale responses so we don't overwhelm clients or services. There are lots of patterns that have to do with maintaining the state of the data or the quality of the data overall. And I do like this modifying data models in production idea. Assume you've got some data service that you use, like maybe Salesforce or some other public service where you store some information. And you decide you actually need to store not just given name and family name, but you want to store an additional name. We'll call it middle name. Well, the thing is, you don't manage that database. That's not yours. You can't convince them to add a new field. They're not going to do that. Instead, you need to create a linked table, a name value pair table, where you can add the information you're looking for and store it locally and associate it every time you get one of the records from the sales database or some other kind of pattern like this. This is a very common pattern. I actually learned this from Microsoft Exchange many years ago. All of the data patterns are based on the notion of making data portable, exchangeable, passable in some sort of way, even when the models on the base change at some point. And then we've got this notion of workflow, or how services interact with each other. Workflow can be very challenging because it's difficult to describe workflow in an abstract way. It becomes very specific. But what you want to think about with workflow patterns is how you can make services themselves composable so that when I create one service and you create another service, they interact with each other in ways that would have worked ahead of time. And the book actually has lots and lots of workflow patterns. We won't get a chance to talk about a lot of them, but I want to kind of cover them again in big chunks. A lot of this notion of workflow pattern is sort of understanding the domain specific notions of the flow of work back and forth, performing a task that is a collection of jobs, reperforming, knowing when something is succeeded or canceled or can be parallelized or has to be sequential and so on and so forth. And then expressing that information. We're pretty good at expressing workflow as code. We just simply write the functions in our coding language. But you can also use a special DSL language, like Ballerina is a DSL that's designed for workflow. Or you can express them as hypermedia documents or XML documents or tickets, or you can even have your own kind of protocol, what I would call a job control language, for just doing jobs themselves. So thinking at the abstract level about how workflow works. And then of course, all the things that we need for workflow, like what is our progress right now? What are all the possible actions? What have we done recently? How can we do a work in progress step by step? Standard list navigation, submitting forms, all these kinds of things that we think about. And then, of course, there's optimizations for replays and incomplete work and short-term fixes and clusters and all sorts of kinds of things. Workflow patterns are extremely powerful. And of course, one of the ones I really like is this notion of a job control language, a sort of meta language about doing work. So maybe I can start from my home page, get a list of jobs that need to be done. Jobs have a series of tasks. Each job has multiple tasks. Maybe I can run all those tasks in parallel and wait for them to complete. And when they do complete, I get a success. but there might be cases where they don't all run and there's a failure or there's a repeat or it takes time. Creating a job control language goes a long, long way towards making your services and your system flexible, which is one of the keys that we want to make. We want to make our workflow flexible. So this has been a pretty quick run. What does this really all mean? When we think about this in the big picture, we want to make designs composable. We want to make clients adaptable to new situations. We want to be able to modify services along the way without breaking our agreement with clients. We want to make sure that we can find data where we need it, even create data when we have to, and create these flexible workflow spaces so that in the future, people can do things that we hadn't even really planned on and the system still works. And in fact, that's actually the underpinning item in all of these workflow patterns, all of these data patterns that I collected in the book. This notion of leveraging your global reach. The internet is this powerful element. Global reach to solve problems you haven't thought of for people you've never met. That's what the internet really is. Allowing people to solve their problems, not your problems. And the fact that they can do that without having to have a meeting with you, a discussion with you, have to write custom code with you. This is something they can do on their own. And that really leads me to the last quote that I want to cover here from Donella Meadows, who's got a great book called Thinking in Systems. If you haven't had a chance to read it, I totally recommend the book. Everything we think we know is actually based on the idea of a model or a pattern or a set of patterns. So we can expand what we know about the world by expanding our ability to think in patterns. And that's what I encourage everyone to do, is to think about this notion of patterns in all of the things that you do. And when you find you can think in patterns, you broaden your horizons and you can help people you've never met solve the problems that they have. I want to thank you very much. That's our talk, and I hope to see you on the web.